Hello. In this episode, we're going to talk about some more examples about solving rational equations. This one we have is right here, negative 10 over x plus 3 equals to 1 minus 11 over x minus 3. First of all, we're going to find the domain. So we have two denominators here. One is x plus 3, and that should not equal to 0. And the other one would be x minus 3, and that should not be equal to 0. Solving these two inequalities, we get x cannot equal to negative 3, and x cannot equal to positive 3. So the domain would be that x cannot equal to plus 3 and minus 3. So we can write it that way. And then we're going to solve the equation. And we have also recognized that these least common denominator would be x plus 3 times x minus 3. And multiply both sides. Right now, we assume that we're solving this equation in the domain. So we're going to take the equation and we multiply both sides by the least common denominator, which means every term we multiply by the least common denominator. On the left-hand side, we're going to reduce the x plus 3. These two are gone. So we have a negative 10 multiply x minus 3 equals to 1 times this product, that's going to be the same. Subtracting 11 multiply x plus 3. And now we're going to combine like terms. Okay, negative 10x plus 30 equals to x plus 3 times x minus 3. If we FOIL that, we should get x squared minus 9 minus 11x minus 33. Now we're going to move all the terms to one side. We're going to move all the terms to one side. And we're going to add the 10x. We're going to add a 10x. And we're going to subtract 30 on both sides. So we're going to do that on both sides. And the result is that on the left-hand side, we're going to have 0. On the right-hand side, we will have x squared. We have x squared minus 11x plus 10x. That's going to be minus x. Negative 33 minus 30. That's negative 63. Negative 63 minus 9. That's going to be negative 63. Negative 63 minus 9 is 72. Minus 72. And if we write it, if we switch the side, if you want to, you don't have to, we don't have to. You would just switch the side, we're going to have that equals to 0. Factor, it looks like we can factor this. Okay, 72, negative 72 is 89. It's 8 times 9. So that's going to be x plus 8, x minus 9. So we got x plus 8 equals 0, or x minus 9 equals to 0. So in the end, we got two numbers, x equals to -8, or x equals to 9. Okay, and we must check if these two numbers are in the domain. So domain check. Both numbers are in the domain because the domain says x cannot be +3 or -3. So we have both numbers are in the domain. And then we're gonna go back to the equation to check, right? For x equals to -8, we're gonna go back to the equation to check. And for x equals to 9, we're also gonna do the same thing. Okay, we're gonna check it. Okay, so this is the proper check of solution. And the left-hand side, we always go back to the original equation. We always go back to the original equation. So this is the left-hand side, and that's the right-hand side. So we're gonna check for both of these two numbers going back to the original equation. So let's do one number at a time. -8 is gonna replace that by -8, and x replaced by -8. And the left-hand side, that's -10 over -8 plus 3. So we're going to do -10 divided by -5. That's going to be a +2. The right-hand side, we get a 1 minus 11 over -11. That's going to be -1. And that's going to be a +2. So left equals to right. Left is equals to right. 1x equals to -8. So we can say, is a solution to the equation. Because the following. For 9, we're going to do the same thing. 9, check. Okay, so we're going to have, this is going to be 9. Over here, we're going to have -10 over 12. And that's equals to -5 over 6. On the right-hand side, we get a 1 minus 11 over 6. Find common denominator. 1 is equals to 6 over 6 minus 11 over 6. And that result is also going to be -5 over 6. So when x equals to 9 is substituted to both sides of the equation, and that will make it a true statement because left equals to right? So left is equals to right. Okay, so in this case, you can see we have two solutions, right? So finally, there are two solutions. Okay, x equals to -8 or x equals to 9. So we have two solutions. And today we wish to go over another situation, which is, we're going to call it example number 3. In this case, we will have, we're going to solve another rational equation. In this case, the equation we have is right here, 3 over x plus over here, 3 over x plus 12 over r squared, x squared minus 4x is equals to negative 7 over x minus 4. All right. First thing first, domain. We have we're going to factor all the denominators, right? The only denominator that needs to be factored is this one. So this equals to x times x minus 4. And we need to guarantee that none of these are zeros, right? So x times x minus 4 should not be 0, right? Should not be 0. Of course, this will make sure that x is not 0. X is not 0. And x minus 4 is not 0. So now x minus 4 cannot be 0. So this will make sure that all the denominators cannot be 0. So in the end, we get x cannot equal to 0 and x cannot equal to 4. So the domain would be all real numbers except x cannot equal to 0 and x cannot be equal to 4. So domain is found. So let's solve it. And we have already found the common denominator here, right? So let's solve it. We take this equation. Okay, so that's our equation. And we are going to multiply the least common denominator, least common LCD, by this least common denominator. I'm going to take this and multiply to every term, i.e. we multiply that on both sides. Right there. And then we're going to simplify. X and x reduce. So the first term, we would just have 3 times x minus 4. And plus x times x minus 4 is the same as x squared minus 4x. So this part we just have 12 equals to x minus 4 and x minus 4 reduce. On the other side, it's just negative 7x. Now we're going to open up the parentheses, minus 12 plus 12 equals to negative 7x. Negative 12 positive 12 makes 0, and 3x equals to negative 7x. I'm going to bring all the x's together, so we get 10x equals 0, and x equals to 0 by dividing both sides by 10. Now, when we do the domain check, okay, x equals 0 is not allowed in the domain, okay? So x equals 0 is not in the domain. Is not in the domain. And that's the only possible number we get. Therefore, the conclusion is there's no solution to the equation. Which is this guy. So from these 3 examples we have seen, sometimes we have, when we solve rational equations, sometimes we have solutions, sometimes we may have 1 solution, 2 solutions, sometimes we have no solutions. Is it possible we may have more solutions? It really depends. Really depends on the situation. And this shows the importance of checking your prospect numbers you've found, going back to the original equation. So always check, domain check and equation check to make sure the number we found is indeed the solution. Thank you for watching.